Hello, ladies and gentlemen of Algebra 2, and you are looking at Unit 7, Note 6, talking about analyzing graphs of a polynomial function. So that's what we're talking about here. So let's take a quick look at this problem. I just want that one, and that one, and that one, and here we go. So the percent of the United States population that was foreign-born since 1900 can be modeled by this function, where t is 0 starting in 1900. So now the graph is decreasing from 5 to 75, and then it begins to increase. The points at 5 and 75 indicate that that's where it's changing direction. So the relative minimum and relative maximum are going to be at 5 and at 75. Okay, so let's talk a couple minutes about what we're dealing with here. So we're looking at three things. When you're looking at a graph, you're looking for three things. You're looking for the real zeros, and that is where the graph crosses the x-axis. Okay, that is the horizontal one. Where does the graph cross that? Because those are going to be your real zeros. The relative maximum is if the graph looks something like this. This is going to be a relative maximum, kind of where it changes direction from increasing. So when it changes from increasing to decreasing, that's an R. So on the graph, so on a graph, like I said, if I've got something like this, that's going to be a maximum right there. Okay, it's changing from increasing to decreasing. I'm looking at my highest point right there. Now, likewise, a relative minimum, sorry about that. A relative minimum is going to be where it bottoms out. So if I have something like this, that is going to be the minimum. Okay, this is where it changes, goes from decreasing to increasing. And it's called relative because there's relative and there's absolute maximums and minimums. Relative means that it is not the absolute highest it can go, but it just kind of changes direction at that place. That is what relative means. So let's kind of take a look at what we're dealing with here. Graph the polynomial function, this, given that x equals -2 is the zero of the function, find the other real zeros, find the relatives and maximums, minimums and maximums, and describe the end behavior. So taking a look, you already know that you have 1, 0 at -2. Okay, so what I can do then is take this function and I can run synthetic division on it. 1, 1, -4, -4. And I can use -2. And I can run drop, multiply, add, so that's a -1, multiply, it's 2, -2, that makes that +4, 0. So I'm left with x squared minus x minus 2. So that's x minus 2, x plus 1 factored. So my other zeros are going to be at 2 and -1. So at 2 and -2, I know I'm at 0. At -1, I know I'm at 0. And at 2, I know I'm at 0. So at -2, 0, -1, 0, +2, I'm also at 0. At 0 itself, I am at -4. So I can fill in the rest of this to help me figure out what my graph is going to look like. So all I'm going to do is put that into a calculator. So x to the third plus x squared minus 4x minus 4. And I'm just going to look at the table. So negative 2.5, I am at negative 3.375. And negative 1.5, I'm at 0.875. At negative 1, I'm at 0. 0.5, I'm at negative 1.875. At 0.5, I'm at negative 5.625. At 1, I am at negative 6. I'm at negative 4.375. So that kind of starts to give me an idea of where I'm at. So at negative 2.5, I'm down here at 3.375. Negative 1.5. At negative 1.5, I'm at 0.875. So then I'm starting to get an idea that my graph is going to kind of look like this. So at 0.5, I'm all the way down here at negative 5.625. At 1, I'm all the way down at negative 6. And then I come crashing back quickly to go that way. So that's kind of an idea of what my sketch is going to look like. Okay, so when I look at this, my maximum is going to be about at negative 1.5. And that's going to be 0.875. 0.875. My minimum over here is going to be at 1, and that's going to be at negative 6. So end behavior. End behavior is what happens as I go this way and this way. So end behavior, as x goes that way, as x is positive, what is the graph doing? As x goes negative, what is the graph doing? So as x goes positive to infinity, this one was going up, so I'm going to say that goes to infinity. As x goes this way, towards negative infinity, it's going to go down, so that makes it negative infinity. So as the graph goes this way, what happens to the function? As the graph goes this way, what happens to the function? That's what I'm dealing with. I have to find all these little pieces in order to explain a graph. Now, looking at the back side, number 2, again, let's walk through this. You are looking at this function, given that x equals 4 is a 0. So I want to run synthetic on this guy with the 0 of 4. So 1, 4, 0, 0, negative 1, negative 4, 0. So this leaves me with x squared minus 1 equals 0. And you might have to do a little bit of thinking on your factoring, but that's actually x plus 1, x minus 1. So my answers are going to be 1 and negative 1. So my zeros for this thing are going to be 4, negative 1, and 1. And you might want to consider marking those down. So at negative 1, 1, and 4 are going to be your zeros. So now, thinking about the function, just figuring out the x-intercept, where does, if x is 0, what's y going to equal? Well, that's going to be 4. So I'm going to have that point there as well. So you can start to kind of get an idea of what the graph is going to look like here. And I'm completely using a graphing calculator to do this for me. I am not trying to be clever and work this out by hand. So I want it back down to 0, By 2, I'm at negative 6. By 3, I'm at negative 8, and that's about where I bottom out at. So I come here, and that's going to be about what that graph looks like. So now, where do I top out? Well, come and ask me, and I will show you on a calculator how to do maximum and minimum, like how to actually calculate where that is. It's not too terrible. It takes about 10 seconds once you get the hang of it. And the minimum is actually at 2.7. And the minimum is actually 8.2, or negative 8.2 as it were. So then maximum is going to be at negative 0.12, and that maximum is going to be 4.06. So now start looking at the end behavior. Again, as x goes positive, as you start looking out to the right, what happens? Well, that goes up, so that's going to be infinity. As x goes negative left, the graph goes down, so that's negative infinity. And that answers my question. That's all I need to do. So now here, oops. Oops, wrong button. Just trying to erase a little bit here. So now, down here, same kind of idea. Negative 1 is a 0. So what I will do is I will go 1, 1, negative 4, negative 4. But the very first thing I'm going to recognize, though, is look, there's an x in every single one. So the very first thing I'm going to do is factor out the x and realize that if there's just x, that is 0. Okay, so if there's an x, one single solitary x I can factor out, that makes it 0. So I've got negative 1 and 0, so I'm already kind of halfway there. So I'm going to run negative 1 on what's left. So that's going to be negative 1, 0, 0, negative 4. And that's going to be 4. That's a positive 4, not a negative 4. So that's a positive 4. So that's going to be 0. So factored, it's going to be x squared minus 4. So that's x plus 2 and x minus 2. So my other two are going to be positive 2 and negative 2. And I'm doing a little bit of erasing so I can have, so I can kind of mark off where I'm dealing with here. So take one more look. Negative 1, 0, 2, negative 2. Negative 1, 0, 2, negative 2. So this is going to do some bouncing around. So now, graph it. So here's kind of what happens. This one is from up above, so please forget that one. So the graph looks kind of like this. So it starts off high, comes down, dips, comes up, comes back down again, and then goes back up like that. All right, so now you've actually got two minimums here, okay? So you've got a minimum here and here. You've got one maximum here. You got 2 points where it changes direction from decreasing to increasing. So that's what you need to calculate. So if I calculate the first minimum, that's going to be at negative 1.6. and that's going to be negative 1.4. So the other minimum is going to be at 1.3, and it's going to be about negative 7. So now the maximum is going to be at negative 0.5 approximately, and it's going to be 0.94. So that's going to be kind of what you're looking at. So now this time, take a look. End behavior. As x goes positive, so as the graph goes that way, the graph goes up, so that's a positive. Now look here. As I'm looking at the graph from going left from the middle, okay, I'm looking at the middle and going left, what happens to the function? Well, that goes up again, so that stays positive. Okay, so that's a change from the other two. But look, both ends go up, both ends go positive. So that's kind of what I'm dealing with here. So let's take a look. Last one. Average fuel in gallons consumed by individual vehicles in the U.S. from 1960 to 2000 is given by this function, where T is the number of years since 1960. Estimate the maximum average fuel consumption and give the year that it occurs. Okay, estimate the minimum and give the year that occurs. So my maximum is going to be probably right there. And let's see, it's not quite at 10. A little beyond 5, so I'm going to go with probably year 7. So that would be since 1960, so that would be 1967. And that's going to be about 718 gallons. So then my minimum is going to be right here. So that's going to be probably at about year 31 or 2. So I'm going with 1992 or 1993, and that's going to be just under 525, so we'll call it 524. That would be my best guess. Okay, so come talk to me with questions and play around with this. Please, please, please come ask me to show you how to do those things on your calculator. All right, that's all I got. Get to work.